Okay, we'll go ahead and start. So our group, we chose to do the single swing for our statics problem. And in this group, it's me, McKenna Martin, Iris, and Gennardo. We'll go to the next slide now. So I'll give like an overview. I don't have the diagrams on this slide. That will be the next one. So if you think about a single swing, it has four bases that touch, and those would obviously be the reaction forces. And it has one swing, which would be a rigid body. And so down here, I have the given information, which that'll make more sense once you see the diagram. And so I'm sure, like all of us have, we've all been on a swing before, even when we were little. So this just gives a real life, like we've all had an experience with a swing to go ahead and analyze. Next slide. So this is the swing diagram. So with the real picture on the left, I couldn't find one without the two horizontal bars in between the four bases. But if you look on the image to the right, it doesn't have those two horizontal bars. The only one would be 2C. So again, like I said, swing, rigid body, it's not moving. You can see the forces of B, C, D, and E pointing up. And then I just have the codes for like 2C. And then on the previous slide, that was given to what that would equal. Then the next one. And so this is our free body diagram. Um, as you can see, we have all the forces going in the direction they're acting. P, that would be I believe we had 180 would be going down. And I believe we did not factor in gravity into this equation or this problem. So likewise, we have B, C, D, E all showing the force is going in the positive Y direction. Obviously P going in the negative direction. And so that's all for the free body diagram.
Our discussion, so this is a symmetrical problem. Since this is a single swing, this means that the problem is also symmetrical, which we must keep in mind that the summation of horizontal focus is zero, and the free body diagram shows the acting forces on the base points, ground points, B, C, D, E, just like McKenna explained. Okay, next slide. Continue. Oh, equations. Um, so the equations show us that we have to look for the equilibrium of our x and our p, which is our pay. We have to sum the resultant force of B, C, D, E, and our pay. The a squared plus b squared equals c squared, that's for our 2A horizontal, our C bar, and then our height, which is our B2 in the free body diagram. Slide. Next.
So these are our calculations which we're solving for reaction forces. So from the equation provided in the previous slide, we calculated that RB, RC, RD, and RE are all equal to 45.75 pound-foot since the single swing is symmetrical. And our summary. So overall, we were successful in this project, and I think we definitely implemented what we have learned throughout the year thus far. And although we did have a few hiccups, including ensuring calculations and equations were correct, We used our knowledge and resources to complete it successfully. And this project highlighted the importance of mechanics, statics in the real world. And although it is in a smaller setting, like the single swing, it's important we begin to see it in action all around us.